In this quick review, I want to talk about the normal distribution, also referred to as the normal curve, and then also talk about something called the empirical rule related to the normal distribution. All right, so what exactly is a normal distribution? Sometimes it's also referred to as the bell curve. So you might see something like this. Okay, please forgive my chicken scratch there, but it looks like this bell shape. Okay, and the normal distribution is bell shape and symmetric about a vertical line through its center. So what that means is if you take a vertical line through its center, if you were to cut the curve in half and fold the two sides on top of each other, they would be the same thing. Okay, and it turns out that the mean, median, and mode are all equal and located at the center of the distribution. So think of this horizontal line here as the data values. All right, and so for this example, let's talk about heights of adult males. And then think about, even though you can't see it here, right? Think about as this curve goes up, that means increasing counts or increasing relative frequency here. And so let's just say the average height of an adult male is 5 feet 9 inches. Okay. And it turns out that actually heights of adult males do roughly follow this normal distribution. What this is saying is the following. Look, most adult males, okay, are going to be pretty close to 5 foot 9 inches. All right. There's some above 5 foot 9, 5'10, 5'11, some below 5'8, 5'7. But the majority of adult males are going to be around that height, this mean. And then as you increase the height, or decrease the height. Like let's talk about people who are 6'5", 6'6", maybe 7 feet, 7'2". There are people who are that tall, adult males who are that tall, but the number of them falls. It gets smaller and smaller and smaller. And it's the same thing on the other side. There are adult males who are 5'5", 5'4", 5'3", whatever. But as you as you decrease the height to the left, all right, it's going to be smaller and smaller amounts. So that's just kind of what the normal curve is telling us, all right? That the majority of people majority of data values for this distribution are close to the mean. And then as you get further away from the mean by increasing or further away from the mean by decreasing, the number of observations falls. And it turns out when something follows a normal distribution, it has this very, very powerful tool called the empirical rule. And it just goes like this. If you have something that's normally distributed and it's centered around the mean, it turns out that 68% of observations are within one standard deviation of the mean. So that means here's one standard deviation above the mean, here's one standard deviation below the mean. And so that means from here to here would be 68% of observations. But then because the curve is symmetric, that means from the mean to one standard deviation is 34, and the mean down one standard deviation is 34, or half of 68. You can expand on this, go out 2 standard deviations. And it turns out that 95% of data values are within 2 standard deviations of the mean. Because the curve is symmetric, that means 47.5 would be from the mean to 2 standard deviations, or 34%, and in this little area here, 13.5%. Same thing on the bottom side. And then finally, it turns out that 99.7% are within 3 standard deviations. So you could go out even more to 3 standard deviations. You can be more or less than 3 standard deviations away, or you can be more than 3 standard deviations away, on either side. And it also means that half of people are above the mean, or half of observations are above the mean, and half of observations are below the mean. All right, let's work one example of this so you can see how to use this empirical rule. All right, and it goes like this. Suppose that the commute time of college students at WCC is normally distributed. On average, it takes them 30 minutes, and it has a standard deviation of 5 minutes to get to school. Okay. What percentage of students have a commute time between 20 minutes and 35 minutes? Well, look, what's important here is the following. 30 minutes is the mean. and the standard deviation is 5 minutes. All right. Now let me go back to that curve on the previous slide. Remember, when something is normally distributed, the mean is in the middle. And then notice how there's these tick marks here. Let me add a standard deviation. Well, the standard deviation was 5 minutes. So 30 plus 5 is 30. Let me add another that gets me 35 plus another 5 gets me 40. And then 45 minutes. And then as I go to the left, I'm decreasing standard deviations. Well, 25-minute commute, 20-minute commute, 15-minute commute. Now check this out. I want to have students who have commute times between 20 and 35 minutes. Well, look, here's 20 and here's 35. These percentages here tell me the students that fall in there. So 13.5% are between 20 and 25, 34 are between 25 and 30, and another 34 are between 30 and 35. So all I would do is just add those up. 13.5% plus 34% plus 34% would give me 81.5% of students have commute times between 20 and 35 minutes. Now let's try this. This is a little confusing. What percentage of students have a commute time more than 35 minutes? Well, look, here's 35 right here. And I know students could have more than a 45-minute commute. It's just such a small percentage. Well, look, how would I do this? I know 50% are above the mean. Well, from here to here is 34%. I don't care about those 34%. I want to be the rest. So I would take that 50% and subtract away 34%. And it would be 16% of students. All right, I hope this quick review just help remind you what the normal distribution was and then how to use the empirical rule. As always, contact your instructor if you need additional support.